Hello everyone. Today I am going to explain a interfacing program, that is write an ALP to generate waveform using a triangular waveform using a DAC interface. Okay. The block diagram of the DAC interface is shown here. First 8051 chip is used and all port zeros, port 0.1, 0.2 till port 0.7 is connected to the 8 pins of the DAC, that is D0. Port 0.0 is connected to D0. The same way till P0.7, that is pin 7 of port 0 is connected to the D7. Okay, and then from the DAC we take a probe, which is a I to V converter, and then it is given to the oscillator. In the oscillator, that is CRO, we are going to observe the waveform, that is the triangular waveform. Now we will see the program to generate a triangular waveform. The program starts like this, that is the origin 0, 0. Since I am doing an interfacing program, I don't start with the initial value 0, 0. I just jump some of the values in the memory and I will start it from 30H. Okay, and then clear accumulator. I am clearing the accumulator because the previous program, if you have executed and if there is some value in the accumulator, that has to be cleared, because I am taking accumulator as the register in which I am going to generate a square wave, which in turn will be sent to the port 0 and port 1. Okay, and I am starting with the label up. Okay, and increment A. Okay, first A is 0 and it goes on incrementing the value, and then from 0 to 01, 02, 03 goes on till FF, because accumulator is a 8-bit register. It can generate only a 8-bit value from 00 till FF. It goes on incrementing, and the value which is incremented in the accumulator will be sent to port 0 and port 1, because I am seeing the output in port 0 and port 1. Next instruction is CJNE, that is compare and jump if not equal. We are comparing the value of the accumulator with the immediate value, that is FFH. Why I am comparing is the triangular wave goes like this. From 0 it starts incrementing 0, 1, 2, 3, 4 like this till FF. Okay, and then when it reaches FF, it has to come down by decrementation. So I will compare. If the increment happens till FF, then I have to go to the next instruction, that is down. If it has not yet reached FF, then I have to go to the label up and it will start incrementing again. Okay, next, first what it will do, before A was 0, now it incremented to 01. Then 01 is sent to P0, that is port 0 and port 1. Then it will compare. 01 is not equal to FF, so it will jump to up. Next again it will increment, that is 02. Again that 02 will be sent to P0 and P1. And then it will compare that 02 with FF. Again they both are not equal, it will go to up. Like this it goes on, this loop will goes on till accumulator value reaches FF. Next, when the accumulator value reaches FF, then we will compare and we get to know that accumulator value and the immediate value FF both are same. So this instruction is not valid, so it will go to the next instruction. In the next instruction, again there is a label called down. Here I will start decrementing the value of A. Now A has reached FF. If I decrement it, it will become FE. Then that FE will be sent to the port 0 and port 1. Again I will compare the value of the accumulator with the immediate value 0, 0. If they both are equal, then it comes out from that loop. If they both are not equal, then it will go to label down. Again it will decrement. So it will go on till the accumulator value reaches 0, 0. After it comes up, again I will jump to up, because one set of triangular value is done, another set has to be done. So again it will go to up. This goes on how much ever triangular wave we want to run. Okay, this was about the program. Now I'll tell you how the program runs. Now the hardware program, whatever changes has to be done, it was explained in the square wave. Now I'll just explain you how it has to be run. The value I have, the program I have inserted here. Okay, then I have to build the target. If I build the target, you can see I have got 0 errors and 0 warnings. Okay, then I will go to debug, start debug session, then okay here. One second. Okay. Okay. I have start debugging now. Next, I will click on run or F5. Okay. You can see the value incremented here. I am sending that, I am seeing the output in port 0 and then port 1. You can see here the value which is getting incremented can be seen here, and the connection whichever was explained in the square wave, it is same for the triangular wave. That is MCP51 is connected to the DAC. Okay, then the supply is given to DAC using plus 12 volts and the minus 12 volts in the regulated DC power supply, and the 5 volts is given to MCB51. And this, in the MCB51 we have RS232, which is used for the serial communication, is connected to your CPU, which is nothing but your RJ11 cable. And then from the CRO, that is the oscilloscope, a probe is being taken, and then the negative of the probe will be given, the ground of the probe will be connected to the ground, and then here I can either connect it to Y out or the X out of the DAC, and I will get the triangular wave which you can see here. And here you can observe the wave which is being generated is of 5 volts. Okay, this is about the interfacing of DAC to generate a triangular wave. Thank you.